Okay. So proofs on test. Okay. So they usually follow the same kind of thing. I know people are probably worried about the proofs, so I want to make sure that I talk about this. Let's see. Let's see. Tablet the reflector. There it is. Okay. The proofs on the test, there's going to be like three different types that you can see. Okay, three different types you can see. Okay. You can also have, so you've got to meet the definition. Maybe I should say four because sometimes they throw a continuity proof on there. We haven't done one of these in a while because I hate them and I wrote the last couple tests, so I don't like them. But you could have meet the definition of continuity. I think there's one of those on the. I think there's one of those on the peer leading review. Oops. Activities. Yeah. Yeah, so you can have something like this. This is one of those first ones, okay? So this is a meet the definition of continuity. Let me actually show you that screen. So there's one of these in the practice test for peer leading, the peer-led exam review. Just meet the definition of continuity. So it asks you to find a C that meets the definition. Watch out for this word justify, because justify actually means prove. Okay? So it's a common mistake just to find the C and move on. But you see this like justifying, that means prove. Okay? So make sure that you know that you don't underdo the problem for those types of things, right? So meet the definition of continuity. So what you have to do for this one is you have to show that the derivative from the left equals the derivative from the right equals the value of the function. Okay? The one on top is the one I'm talking about, where you have to meet the definition of continuity. And the strategy you want for those is show the limit as x goes to a minus of f of x equals the limit as x goes to a plus of f of x. And then show that the limit as x, so limit exists. And then show that the limit as x goes to a, which you now have, of f of x equals f of a. And it's very common to forget to do one of these things. And they're worth a lot of points, and you'll know it, and you'll be fine with it, and you'll forget it. So just remember, you need to show those two things if you have one. And the strategy is just to, right? So if I've got this problem here, so for an example, show the square root, show f of x equals sine of 0 is 0, yeah. Sine of x if x is less than 0, and x squared if x is greater than or equal to 0 is continuous. I should have put cosine. Right. Show that this function is continuous at x equals 0. Right? So how would I do that? Well, I need to show that the limit from the left equals the limit from the right equals the value of the function. So I need to just walk through it. So the limit as x goes to a minus or 0 minus of f of x equals the limit as x goes to 0 minus cosine of x equals cosine of 0, because it's trig, so I can direct sub on a trig, which equals 1. The limit as x goes to 0 right, f of x equals the limit as x goes to 0 right of x squared plus 1 equals, with a direct substitution on a polynomial, 0 squared plus 1 equals 1. And then the one that everybody forgets to do is to actually check what f of x is. So you forget to check that last number. The limit, so you forget to check that f of 0 equals, here, 0 plus 0 squared plus 1 equals 1. So people will forget this last one, so don't forget it. Right, so what I've basically shown is that the limit from the left is equal to the limit from the right, and which means the limit exists and that it equals that. Okay, so how do you feel about what you have to do for those types of problems, 1 to 5? Let's see, 5 pole problems. Okay. Yeah, so you can do direct substitution if the equation meets certain criteria. Those equations are basically, right, I could directly substitute here because cosine is continuous. I'm not saying f is continuous here. I'm saying cosine is continuous, which is true. You have to do this last piece because it's part of the definition. In order to show continuity, you have to meet, that's part of the definition. You have to show that this is true, which means you have to show that this exists and then show that that's true. So in one sense, another way of saying this show the limit exists and show it equals the value of the function. Another thing that's helpful, again, is draw a picture, even though it's not a proof. Draw a picture. Because that'll help guide you about what you're doing. So, you know, just throw a couple of little points on there. Like if I was doing this one here, what would I do? I'd do x squared plus 1 is like here, and I'm going positive. That's kind of like this. Cosine's going to look something like this, and cosine of 0 is here, so it's going to look something like this. That's not big enough. Right? It doesn't have to be a perfect picture. It's just got to be a you know. It's not a proof, and it will get you points, but it won't give you the full points. You actually need the proof. But, you know, it's kind of a little, you know, guide to what I'm doing. You just need to say DS, directly substituting, and you don't really always need to do that. You know, DS poly is like, you know, is neener. You're kind of showing off at that point. Okay. Meet the definition of continuity. That's one that I don't like, but they have shown up before. Okay, and then you've got this kind of prove the derivative is something. Okay, and on this, you need to use the definition of the derivative. Okay, for most of them, I recommend the H definition. And I went over another example of how to do this on the 5 p.m. quiz that I didn't do on the 11 a.m. quiz. So you might want to check out for another example. Check out review of 4B from 5 p.m. Because I actually I did another example on that one. But you have to use the definition of the derivative. If you use the power rule, you get, or the sum rule, or the constant multiple rule, you're going to get smacked in the face. Okay. Any questions about that? So how do we feel 1 to 5 about using the definition of the derivative? No, you don't need to use the binomial coefficient. So, as I said, if we give it to you, if you need it, we'll give it to you. You won't need it, or at least I don't think so. I don't think she's going to do x cubed, and if she did, I would fight her. I would tell her, why are you doing that? You either need the binomial theorem or, which, I would actually, what I would say is, I put that on a quiz. And then she'd probably take it off. I wouldn't actually fight her. I'd say I put that on a quiz, so you might not want to use it because all my students are going to get it. The T definition. Okay, so let's say I'll do an example. What time is it? Okay, so for example, let's do a T definition example. So x squared is in packet 4. Do it both ways. Let's do the square root of x. Okay, so prove d over dx of the square root of x equals, what is this? It's 1/2. Sorry, I'm going to have to do it for myself over to the thing, right? It's 1/2 times x to the, it's 1/2 x to the negative 1/2. So it's 1 over square root of x. 1 over 2 root x. Okay. Ugh. My brain's not there right now. Okay, so I want to prove this. So this is that exact same question that I had before today. And I know my head's in the way. All right, so what I'm going to do is I'm going to use the T definition. So here my strategy is going to be using the T definition. And I want to show that the limit as x goes to, t goes to x of f of t minus f of x over t minus x equals 1 over 2 root x when f of x equals the square root of x. Okay? Now I'm going to be very careful not to make sure that I don't do that. Okay. They're exactly they're the same in that they're algebraically equivalent, but they're slightly different in their form. So let me show you. If I'm using the t definition to do this, here's what I'm going to do. I'm going to do, okay, so I'm going to do f prime of x equals the limit as t goes to x of the square root of t minus the square root of x, right? Because that's f of t is the square root of t. And f of x equals the square root of x over t minus x. Okay. Now, I can either multiply by the conjugate, or I can break up the bottom. Okay. So what I've just done is a difference of squares on this, right? So I've said that t equals the square root of t squared and x equals the square root of x squared. Okay, this is the difference of squares, but it's a little bit more abstract because I don't have a square up here, right? I've got just t, but it's really the square root times the square root. And then these two things are going to cancel, and I'm going to wind up with the statement limit as t goes to x of 1 over root t plus root x. All right, and since I'm taking a limit, t doesn't equal x, so what I'm going to do is I'm just going to sub it in. And so what I'm going to do is wherever I have a t, I'm going to replace it with an x. Okay, and then I get 1 over 2 root x. So that's the t to x definition. Okay. I could have done this with the h definition of that way. If I wanted to do the same thing with the h definition, I'd do the limit as h goes to 0 of f of x plus h minus f of x all over h equals, I need to put f prime of x here, don't I? Now, my x is the square root of x, so f of x equals the square root of x. That means f of x plus h equals the square root of x plus h. And I'm going to wind up with the following. Okay, this is fine. And then the x's cancel. And when you multiply the conjugate, don't multiply out the bottom. Just leave it. You should be able to do any of them. So whatever floats your boat. Usually the x plus h definition is going to be cleaner. That's not, the square root of x is one of those where either definition works really well. X squared is also one where either definition works really well. So it's a matter of taste. We try to do ones where either one will work. Some people like one definition, some people like the other. We tend to pick ones that either of them work. But, you know, it's not always doable. So if you like the other one, go for it. Okay. All right. The next one that's common is 2 cops and a drunk. So you've got a limit of something drunk. All right. So on the bootleg, let's see. Are there any on this one? And these can be hidden in the regular limit problems, but usually they're not. Usually they're separate and they're worth more points. I remember one year we hid one in the thing and I was opposed to it, but we did it anyway. And just people were confused about what to do, which was sort of the point, which was, to make you actually look at the problem. But in the past, we've decided against that. So here, let's see. Is this a two cops? No. That's an intermediate value problem. Oh, bugger. I don't think there's one on here. What about a bootleg? Here's one. All right, so this is a two cops problem. This one is a two cops problem from one direction. That one example, x squared sine 1 over x is always a popular option. You can do things like cosine of 1 over x. So if you take cosine of 1 over x as x goes to 0, it equals 1. Not of cosine 1 over x. It doesn't exist. X times cosine of 1 over x would be 1. We usually do something like this if we do it. X squared is the one that's x squared sine 1 over x is your thing. So the key is, the strategy is to use two cops on these. Did she cut the other one? I think she did. Oh, this is quiz 3B. This isn't my bootleg. Yeah, I did. Oops, shoot, there's a typo. That should be a 1. Ah! And it's not my typo. This is what happens when you let the... This is what happens when you let people play with your stuff. It is 1, right? Let's Desmos this real fast. I may be stupid. It's late, so it may be me that's doing it wrong. Nope, she's right. It goes to 0. Sorry, bad me. That goes to 0. So limit of something drunk. She's right. I'm wrong. It's late. So you can see here. Let's take this problem here off the bootleg, right? You can see here that f of x is squeezed between two things where the limit goes to 4, right? So, I'm sorry, not the limit of 4. As x goes to 4, right, both of these equations are polynomials. So if you compute what these equations are, you get a number, right? That particular number is going to be 7. All right, but it's not just enough to say 7. You have to prove that you're correct. So it may say something like show you're correct, or justify your statement. That would just be mean. But remember, justify or show means proof. So what you're going to do for these, so is everyone on board with that? When someone says justify or show or one of these nice things, they mean prove. What was I doing? Phi pole. I don't want you to mess that up because that's annoying. So what is that question asking you to do? That question is asking you to find the limit and then prove that you found it. Okay? So if I propose that the limit is 7, okay, what do I have to do here? Okay? So the strategy is to use two cops. Okay? So if I'm going to use two cops, I need to do two things. So need to do. One, show for all x near a that the limit as x goes to a of top of x equals the limit as x goes to a of bot of x. And then I need to show that, for all x near a, I'm sorry, I'm screwing this up. I've just mixed up my things. Let's let you go down here. So I need to show for all x near a that top of x is greater than or equal to f of x is greater than or equal to bottom of x. Okay? So I need to show that it's squeezed between two things and everyone's heading to the place. Well, I'm glad you can't see what I was writing because I was screwing it up. Okay. And so let's do an example. Let's do, I know a function is trapped between, let me see, where's the textbook? Okay, so here's one from the textbook. All right, so in the textbook I've got, this is number 34 on page 44. You don't know what the page that is because the ebook doesn't have that. They don't have page numbers anymore. 1.4, section 1.4. Okay. So I've got if 2x is less than or equal to g of x is less than or equal to x4 minus x squared minus x squared plus 2 for all x. Find the limit and justify. Find the limit. Where is it going to? As x goes to 1. Okay, so here's an example of a two-cops problem. All right, so what I'm going to do this is I'm going to do, my strategy is two cops and a junk. And I want to show something. I want to show that the limit as x goes to 1 of g of x equals 2 times 1, which equals 2. And how do I know that? Because I stuck 1 in for that number, which was kind of easy. Okay? But that's what I want. That's the conclusion of two cops. The conclusion of two cops is that the limit of g of x is top, or bot. Okay? So I need to show that that holds. So what do I have to do? I have to show two things. And I have to show that the limit as x goes to, what is the limit as x goes to 1? So I need to put a 1 here. Limit as x goes to 1 of top of x equals the limit as x goes to 1 of bot of x. So how do we feel about what has to be shown, 1 to 5? Because 2 cops tells me if these two things are true, then it has to be the case that the limit of g is what I say it is. And another one that I've seen, I'll go over this real fast, but it's, so this is what I need to show, and I need words basically here. Okay, so here what I'm going to say is actually pretty simple, which, makes it hard because you're trying to say something simple. Okay, let top of x equal x to the 4th minus x squared plus 2 bot of x equal to x by the statement of the problem. Top of x is greater than or equal to g of x greater than or equal to bot of x everywhere and near a, and near 1 is somewhere. Okay, now I need the second part. And this is way too much verbiage. I would have just said, let top be this, bot be this, by the statement of the thing, top of x is greater than or equal to g of x is greater than or equal to bot of x near a. But the point is that I've actually showed the condition. The second thing. So the next thing is that I need to show that this is true. So I got limit as x goes to 1 of top of x equals the limit as x goes to 1 of x to the 4th minus x squared plus 2 equals, by direct substitution on a polynomial. Again, if you say polynomial, you're just bragging. 1 minus 1 plus 2 is 2. Limit as x goes to 1 of bot of x equals the limit as x goes to 1 of 2x. It's another polynomial. Or I could have said constant multiple law and then did another thing and pulled it out, but I'm not going to because it just takes forever. 2 times 1. Note I did that step. 2 times 1 equals 2. So by 2 cops, the limit as x goes to 1 of g of x equals 2. Okay. How do we feel about that? Okay, so it's not always specified, but we're not going to give you one that's crazy. Like there's one in the textbook where you have to draw a graph first. The really hard one are the ones where you have to use absolute value to make it work if you want to do both sides at the same time. Someone had asked me about the one-sided thing. The book only has the two-sided version, and it doesn't have the infinity version. So the that. Now, there's a wrong thing, and I want to show you this thing that is wrong. Okay, because I've seen it on a couple of your proofs that you're doing this. So I've seen this a couple times. Sorry. There's a limit of x goes to 1. And then I see this. Okay. What is wrong with this statement? Well, that's a problem. So the first problem is this, okay? Two problems. One, the second line assumes the limit of g of x exists in the first place. It's kind of smooth, right? Because it's got like 2 is less than or equal to this number, which is less than or equal to 2. So it looks really cool. Okay? It looks cool, but it's actually incorrect because you've assumed that this exists. The second one is this. You can get into trouble saying that the limit as x goes to a you can get into trouble by saying f of x, I think it's g in the textbook, so I'll use that. G of x is less than f of x is less than h of x. Therefore, the limit as x goes to a of g of x is less than the limit as x goes to a of f of x is less than the limit as x goes to a of h of x. Because this is actually false. Can someone give me a counterexample of this? Can someone give me an example of a function that is always less than another function? Okay? But their limits are equal. Consider this. Consider 1 over x and negative 1 over x as x goes to infinity. Okay? It is always true for all x greater than 0, it is true that negative 1 over x is less than 1 over x. But it is not the case that the limit as x goes to x of negative 1 over x is less than the limit as x goes to infinity of 1 over x. 1 to 5, how do you see that? How do you feel about that? These less thans can get you into trouble with a limit. This is not a function. Oh, crap. It's doing this thing. So this limit thing is not a function. I can't just throw limits around. They've got properties. And I don't want to confuse you on this. I just want to tell you not to do this. Right? Because both of these are 0. And it's not the case that 0 is less than 0. It is true that it's less than or equal to. All right? So I don't want to confuse you. But I'm just saying don't do this. Because you can wind up into trouble. Do this. Okay? You have a theorem. So there's no need to be clever. There's no need to be fast with it. Just show that you meet all the conditions. Okay? All right, the final one. So how do we feel about that 1 to 5? As I said, I don't want to confuse you. And if you feel confused by what I just did, don't do it. Just take from this. The only thing I want you to take from all this crap is don't do this. Okay? There are problems with it, so don't do that. That's all I really want you to take from this. I don't want you to don't confuse yourself. Just don't do this. When you have a theorem, don't try to be clever, slick, or only write symbols. Just show that you meet the two conditions. Treat them like a checklist. I'm losing people, probably because I'm yakking too much. All right. Are there any questions about 2 cops? All right. All right, the last one, the very last one that I want to talk about is the continuity proof. I'm sorry, using the IVT. So this is, there exists a root or solution or something like that. Okay. So I've got a continuous function and I've got, and I want to show that there exists a root or solution. So let's do one in the book. Okay. So the strategy is to use the intermediate value theorem. Okay, so what do I need to show? If I want to use the intermediate value theorem, how do I have to set it up? What do I have to do? What do I need to do? Somebody tell me. What are the two things I have to show in order to apply it? Right, I need to show it's continuous. And what's the other thing I need to do? And show that V is strictly between f of A and f of B. All right, so let's do an example. I'm all over the place here, aren't I, here? I think I'm going to delete this when I do this. I'll probably put the examples at the bottom. Let's do an example. This is problem 40 on page 50. Oh, you don't have page numbers? Section 1.5. Okay. So the first thing I'm trying to show is that f is continuous on the interval I want, and v is strictly between. All right. Okay. All right. So this is problem 40. So it says show there is a solution or a root to the equation the cube root of x equals, oh, I hate getting old, 1 minus x on the interval 0, 1. Okay? So what is this thing asking me to find? How do we feel about what it's asking me to find? So phi pole okay. So the fact that I've done this is annoying. Okay? So what I'm going to do is I'm going to rephrase the problem. And I'm not the biggest fan of these, but because I don't even have an F yet. But what I'm going to do is I'm going to say that I'm going to change this. I'm going to call f of x. So what I want to show, this thing right here, is really the following thing. This equation is actually that the cube root of x minus 1 plus x equals 0. Yes, bootleg. Question 11 on the bootleg is also an IVT problem. Okay. All right, so is everyone on board with now what I'm trying to show? If I rewrite this equation, if I subtract the right side from the left side, I'm sorry, I subtract the right side from both sides, right? I subtract 1 and I add x to both sides. I wind up with 0 on the right. So it's actually kind of a hidden. This is one of those places where writing an introduction really helps. I want to show that f of x equals the cube root of x minus 1 plus x equals 0 on the interval 0, 1. Right, so now I've got an f. Now it looks more like an IVT problem. I just need to figure out what the thing is really asking for. And so it says a root to the equation. That's kind of, functions have root, not equations. It's a solution to the equation. All right. So my strategy is going to be using IVT. Now, I don't know if you can see this, or if you remember, if I didn't really go over it, but I think it was mentioned in peer leading. Cube root of 3 is continuous, and this is a polynomial, so it's continuous. And if I take two continuous functions and add them or subtract them, I wind up with a continuous function. Okay. So what I'm going to do is this. I need to show two things. And I need to show zero is strictly between, I'm sorry, I need to show that it's continuous on the closed interval. Thank you. All right. And I need to show 0 is strictly between f of 0 and f of 1. So how do we feel now about what you kind of have to do? Oh, you can ask me questions about it during office hours. I'll be happy to help. I'll be happy to give you hints to it if you want hints. I've talked more than I wanted to, but you guys were asking me for examples, so I'm doing it. Okay, so for this first part, what I'm going to say is the following. Cube root of x is continuous as a radical on its domain. And 1 minus x is continuous as a polynomial. Thus, their algebraic combination, the square root of x minus 1 minus x equals f of x, is continuous everywhere. So, continuous somewhere. All right, so this is like just properties of continuous functions. And you'll find them listed in this section 1.5. where they go into every function. I didn't really go over it because it's one of these like minor things that's like obvious in one sense, and it's also kind of boring to talk about. But I could do it if I wanted to prove them. You could do it using limit laws. So this is there it is. It's Theorem 6 in section 1.5. The fact that the radical functions, the root functions, are continuous on their domains. And then the composition, I didn't talk about that. Theorem 7 is actually important in that, but it's not really for us yet. Okay, it actually didn't do that theorem that the algebraics are continuous. That's annoying. Okay. Anyway, they are. So, yeah, I didn't want you to record. I'm actually recording because I might pick off little pieces of it. But I'm not sure if I'm going to have time to edit it, so don't count on it. I am going to post these notes, though. All right, and then what I'm going to do is I'm going to put, like, here what I'm going to say then is f of 0 and f of 1. So what I need to do is show that it's strictly between that. So I got to do f of 0. So f of 0 equals the cube root of 0 minus 1 plus 0, which equals, well, let's see, cube root of 0. I think it's 0 times 0 times 0 is 0, right? Yeah. And negative 1 plus 0, yeah. And then I've got f of 1 equals the cube root of 1 minus 1 plus 1, right? And so this is 1 minus 1. That's 0 this week. So that's positive 1. So v equals 0. F has, there exists a V, there exists a U. In, what is it, 0, 1. So that F of U equals 0. So there is a solution to cube root of x minus 1 plus x equals 0 on 0, 1. So, which is the same thing as the other thing. This is all like fluff. I don't need to say any of this. I just need to kind of stop there. But if there could be a thing asking you for the conclusion. But okay, so how do we feel about that? I mean, that's kind of long and annoying, but that's how you kind of do it. You just need to meet the two conditions. So IVT problem. So the real hard part about the whole thing is figuring out how to put it in the terms of the IVT, right? I mean, the two things. First of all, the it's a polynomial. In fact, I could have cubed the whole thing and made it a polynomial and still been fine. Um, so yeah. Are there any questions? So those are kind of the 4 proofs that you can see. Okay. Oh gosh, it's already 8:24. All right, let me go over just a. If you've got questions, by all means, ask them. I actually wanted you to be asking more questions, but you guys were saying that you wanted those things. So okay. And then there's always, if you look at the bootleg, there's usually something like this. As a matter of fact, this is a test question from before. Okay. And when they do these questions, you need to actually work out the numbers, okay? So over what intervals is Tommy's velocity 0? Well, 1, 3, 5, 7. Why? He's not moving. The slope is flat. All of those things are good, but you actually need to say this thing here. You need to say something here. This is a common mistake, is to just give the intervals and not give this. The derivative is 0. The slope of the tangent line is 0 over that interval. All of those things, he's not moving over that interval, but you need to say why. And then you need to find the instantaneous velocity at t equals 8. So what you need to do is you need to go to like 9 and 7. So in order to justify this instantaneous velocity thing, and I want to mention it just because it's on every test, like in the last 4 years. And this is a common mistake. So justifying instantaneous velocity on the graph. Here's how you do it. Okay? When you need to justify, you need to say the following. Okay? And this is really important. So what you have to say for this type of question is you either need to do rise over run or you need to do the things, right? So the instantaneous velocity is the same. So you need to say something like this. Okay. So say something like the velocity is not changing. Say that the line tangent to a line is a line. You can't see it, again, because I'm not thinking. Sorry about that. So say something like the velocity is not changing. The line is tangent to the slope. Say something like rise over run. But just do this, okay? So on this particular equation, do f of 9 minus f of 7 over 9 minus 7. All right, and then that is f of 9 is 1, f of 7 is 2, over 9 minus 7 is 2, which equals negative 1 over 2. And then don't forget your units. So this is meters per minute. Okay. So let me actually just put the butter, new section, test review. So this is S. I do this, and then I do this. There you go. All right, say something like this. The velocity is not changing. It's a straight line. The line tangent to a line is a line. And then just do rise over run. You can also get away with this if you want to. You could even do this. Rise equals 1, run equals 2. Right? But you have to do something to justify it. I hate that. Remember that show all your work actually kind of means proof. How do you feel about that 1 to 5? Just say something that lets you know, lets the grader know, or communicates that you understand this idea that the slope of a tangent line of a line is just the line itself. So locally, you know, you can get the slope of that tangent line by just doing rise over run there. Just something that says that. Okay. Are there any more questions?
Wait! Wait! Where are you going? I was going to make espresso.
Okay, you could ask me more questions. Just that people were leaving, so I started doing that. Question 14. Okay, so question 14 is one of those, yeah, man, let's talk about it question, right? So the idea here is there's two ideas. One, to get you used to the DT over the symbol, right? So, by the way, math is case sensitive. So please respect the case sensitivity of the math. And the other part of it is like, what happens? What's the derivative? What's changing? So this is really related. Question 14 is really related to the problem set that we were working on today. So question 14 is very, very similar to problem set 4, this page. Okay? So it's very, very similar. You can't see the page I'm pointing at because I don't remember to do that. It's very similar to this page here. On problem set 4. Okay, it's very similar to this. It's kind of one of those let's talk about it kind of problems, right? So it doesn't really have a B and an A, but it's got kind of these things. What does it tell you about the oven? You know, it's kind of the same thing. What is this telling you? What's this intuitive notion around the derivative? And it's trying to get at this kind of thing. Right? When is F increasing? When is F decreasing? Does that make sense? Okay. Okay, so that was which one was I talking? That was 14. 12, I'm going to tell you to go look at the notes and watch the lecture tomorrow. But what you have to do, I will give you a hint. On 12, what you need to do okay, you want to show the two definitions. So you want to show that so let h of h is going to be a bad thing. Let L of x equal f plus g of x. And so what you want to show is that L prime of x equals f prime of x plus g prime of x. So you want to show that the limit as h goes to 0 of L of x plus h. Yeah, sorry. I'm doing it again. So you want to show that the limit as h goes to 0 of this L of x plus h minus L of x over h equals the limit as h goes to 0 of f of x plus h minus f of x over h plus the limit as h goes to 0 of g of x plus h minus g of x all over h. And if you look in the notes for Thursday, one of these is actually in there, and it might be different, this one. But this is what you want to show. So the key is figuring out how you want to, what you want to make equal to each other. And that's the hint I'll give you on 12. 7a, I'm not going to do it. 7a, you're going to have to factor. And the factoring is not going to be the prettiest thing. But if you factor the top, is this a factor problem? What happens if you plug it in? You get 9 here. If you plug it in, you get 2 times 9 plus 7 times negative 3 plus 3. So you're going to wind up with 18 plus minus 21 plus 3. Yeah, that's ugly. So you're going to have to factor this thing. And that one is kind of a bear to factor. But if you look at the top, you're going to see that it's the top is t minus 3, t plus 3. So you know it's going to be one of those. So when you throw in t plus 3, if you divide the bottom by t plus 3, you're going to wind up with something plus 1, I think. So if I do t plus 3 into 2t squared plus 7t plus 3, let's see. So t goes into 2t squared, 2t times. You're going to get, so that's going to give you 2t squared plus 6, 6t. So you subtract down, and you're going to wind up with 0 plus t, bring down the 3. Yeah, and that'll go in nicely. So this is a 1. You multiply the 1 over, you get t plus 3, subtract, and you wind up with 0. So that's it. So this is going to factor into the bottom ends up factoring into t plus 3 and 2t plus 1. That's unpleasant, but that's what it is. Bet you didn't know that trick. I bet that thing is new. Is this thing new for you? 1 to 5 on that little trick there for long division. I bet we didn't remember how to do long division. So that's one way to do it. I mean, you can just play with it. You figure it out by the fact that it's, a 3. So it's got to be a 1. And the only other thing it can be really is 2 because you got a 2 on the other side. But the long division is kind of fun. So that was 7A. People were asking for 12. I already mentioned all I'm going to mention about 12. Right, you can't DS. It's not that it's D and E. It's that you get 0 over 0, so you have to do more work. And 15. Okay, so 15, I've given you the hint. So 15, if you watch yesterday's lecture, I actually did B. I actually did the limit. I did this one in yesterday's lecture by accident. So let me show you that screen there. This one I actually did by accident yesterday. I'm sorry, Monday during lecture. So if you watch the lecture video, you'll see me actually work this portion out. And once you see that portion, you just plug it in and show that the limit. You show that the derivative is heading to infinity, which is bad. So that one's easy. This one right here, you need to break up this function. So the hint for this one, I mean, there are 2 hints. The first is that you can use the x to t definition for this. The other hint is right here. So you need to remember that this ABS function is 2 things. So the hint for this part, the hint for this part is to know the following. So the hint for, oops, that's a. Oh, so this is 15a. Is f of x equals the absolute value of x cubed, or this, same thing, is the same thing, this absolute value of x cubed is the same thing as negative x cubed if x is less than 0 and x cubed if x is greater than or equal to 0. So what you have to do on this one, on one of them, is show that the derivatives don't equal each other. And on this one, you actually have to show that the derivatives do equal each other, despite the fact that there's an absolute value in there. Okay. Any other questions? I kind of already gave you the hint. It's so you. I'm not gonna do any more than that one. No, you don't need to put. You either need to say. If you say it exists, you need to write the function. If you think it doesn't exist, you have to use the theorem. Seven C. This one, this one is supposed to be an infinity minus infinity type thing, or where this thing doesn't exist. So what you have, this is an example of another indeterminate form, infinity over minus infinity. But what you kind of have to do is just take a common denominator. So you throw the t up here, you throw the t squared plus 2t here, and then it's just it's algebra that's unpleasant. It's just unpleasant algebra. So you have to take a common denominator and then mess with it. Let's see. So that's we're talking. Okay. I think it's back now, right? Discord. Yeah. Okay. So yeah, that problem is just unpleasant. There's going to be not as much unpleasant algebra. So, is there a time limit for the bootleg? I think it's 120 minutes. And I think I gave you 3 attempts or something like that to make it work. Proctoria for really long things likes to go. So, you know, I gave you there's 3 attempts. So if the Proctoria thing stops in the middle of it, you can start it back up. So you really don't have a time limit, but you know, I guess it's 120 times 3. So if you need 6 hours for the bootleg in one setting, okay, but you know, the Proctoria requires an actual time limit. So, but I give you 3 attempts on it and whatever. Are there any other questions? All right, so it's it's almost 9 here. We've been up at it for an hour and 45 minutes, hour and 50 minutes. So I think that's it for today.
That's it. Let's roll. Hey, let's be careful out there.